So quality assessments are reliable. That is, if it's a quality set of assessment items measuring either a single or a group of related outcomes, that then the people who are taking the assessment will respond consistently, whether it in pre-test mode or in post-test mode after the instruction, that there's some consistency with which they respond to a set of items. So the main principles of reliability are going to be presented here. Let's give you a quick sort of example based on the previous Lavanusium procedure example that was provided here. One of the items was a true or false. And the way it was worded was that pressure settings are commonly adjusted before initiating the Lavanusium procedure. Well, imagine if this item actually used the word always instead of commonly. So in this case, somebody taking the pretest might look at this item and say, well, the word always almost always negates the statement from being true. That's one of the bad words that you don't use when you're developing a true or false item. So let's say that somebody read this item, they saw the word always, and they immediately answered false, regardless of what the rest of the item said. So in terms of reliability, they may not have answered the other items correctly consistently with any sort of pattern above chance. But then this particular item, most of the people taking the assessment before the instruction still get this one correct. Not because they understand it based on applying the procedure to the real world, but because they understand that the word always is a cue making the statement false. So that an item that is poorly worded can contribute to poor reliability, because the reliability within the four items themselves might point to this item being answered correctly in a pretest way more often than it should be given to chance. So that's why the whole concept of reliability is an important concept to address. So what follows now are some of the common ways in which reliability is measured. That is, the consistency of responding is measured when you are implementing an assessment. The first type of reliability test that is discussed in the text as well as here is called stability reliability, and that is test-retest. This is a measure of reliability in which you implement the same assessment to a group of learners at a particular time, and then at some time later you administer the same set of assessment items to the same population. If it's reliable, you should expect the same general results. This applies to whether it is a pre-test or whether it is a post-test. So that is the stability reliability, or test-retest. Commonly used way to measure reliability is to have a set of items that measure a particular outcome, and to have two different related sets of items, and you administer those items at the same time with a set population, randomly selected item, or set 1 versus set 2. And if the items function reliably, again, whether it's in a pre-test mode or a post-test mode, then the performance on both sets should be consistent. And that would be a way of measuring evidence of reliability based on what is called alternate forms. Now, another way to measure the reliability of an assessment is to measure the internal consistency of responses. And this relates back to my example that I had previous, where you have these 4 items that are measuring the application of the Lavenusian principle, and you want to measure whether or not each item within that set functions properly as a collection of items. And if you have one item that does not function properly, like a true or false that is just not worded well, then you can identify that by doing what's called a split half correlation. And what the graphic on the screen illustrates is, in a split half correlation, what you do is you take all the items in an assessment and you look at how you randomly select half the items, and you look at how well the people responding to one half of the items, how their performance on that half correlates with their performance on the other half of the items. And again, in terms of consistency, if the learners know their stuff, then they should perform about the same on one half of the items as they do the other half of the items. And if they don't know their stuff, or they can't apply those skills within those items, then they should perform equally as poorly on one half of the items as the others. And there is a way of calculating that kind of response pattern using a correlation. And if you know anything about correlations, correlations run from -1 to +1, with a +1 being a perfect positive correlation. That is, if they do well on one half, they do equally as well on the other. A negative correlation would be, if they do well on one half, they would do poorly on the other half. That would be a negative correlation. And the numbers are between -1 and 1. In this case, having a split half correlation coefficient number at 0.88 would tell you that how well the respondents did on one half of the items correlated very strongly with how well they did on the other half of the item, other half of the items. Another way to measure the internal consistency of a set of items is by calculating the average inter-item correlation. So for example, if you look at this this chart on the screen, again, we have an assessment set of 6 items, items 1 through 6. And in this case, when you correlate performance on item 1 versus item 1, it has a 1.0 correlation. That is, however anybody responded to item 1, it correlates perfectly with how well they responded on item number 1. That is, they either all got it right, or they all got it wrong, or the collection of those who got it right. Obviously, the correlation between the same item is going to be consistent. But in this case, if you look at how well do the learners respond to item 2, 3, 4, 5, and 6, based on how well they responded to item number 1, in this data, it correlates very highly with all of them. And so how well they performed on item 1 correlates very highly with how well they performed on item 2, or how poorly they performed on item 2. And it's the same for item 3. If they did well on item 1, they did well on item 3. If they did poorly on item 1, they did poorly on item 3. So in this case, these correlations are all very, very high with each other. That leads to an average. If you average all the correlations together, it leads to an average inter-item correlation of 0.91. That is very high. So in the case of the example I gave earlier, that means that let's say that item number 4, or item number 2, the true or false item, was written well, did not use the word always, but used the word commonly. So in a case like that, that means that however you responded to item number 2, if you got it right or wrong, you responded similarly to the other items. That is, if you got item 2 right, you tended to get item 1 and 3 and 4 right. Or if you got it wrong, you got the other ones wrong. That just shows that, so these numbers in average, if you go to, let's say for example, in this case, that you have an item number 2 that correlates very poorly with the other items. So item number 2 in this case correlates almost completely negatively with item 3. That means that if you got item 2 right, you got item 3 wrong. Or if you got item 2 wrong, you got item 3 right. You'll notice that in data like this, it shows you that there's a real problem with item number 2 because it correlates very poorly, very negatively with how well people responded to the other items. And that can result in an overall very lower than you want average inter-item correlation. Data like this would suggest that there's a real problem with item number 2 because what it shows is that if you did well on the other items, you tended to do poorly on this item. Or vice versa. If you did well on this item, you tended to do poorly on the others. This could really be indicative of a poorly worded item or of an item whose correct answer is actually improperly keyed. But it definitely, data like this can show you how important the reliability coefficient is because it can show you or point the way to a very poorly worded item. So that's just another example of how internal consistency reliability can help you identify poor items. Now, another type of reliability that is used very regularly when measuring the reliability of an assessment item, particularly if your assessment is something like a rubric or a checklist, is something called inter-rater reliability, and you're probably a little more familiar with this form of reliability. What reliability shows you is the relationship between one observer scoring a set of performances and another observer using the same key, using the same assessment scoring, how they relate or how they rate a set of observations. And so if you have a good assessment, that is a really good, clear set of criteria or of items, then one observer will score similarly an observation the same way another observer would. And I'm using in particular this example on the screen of learners perhaps carrying out a scientific test where if you're trying to measure whether or not they're doing a set of procedures correctly, rather than having a multiple choice quiz or some type of standard paper and pencil assessment, you might use an observation checklist. And if it's a good checklist, then one observer will respond in similar fashion to another observer while observing the same phenomenon. This is used actually in the literature very commonly. Here is a graph that depicts one observer on the left, observer Y, going up the y-axis, using a test, a checklist of an observation protocol, teacher observation protocol. And so in this case, it's a revised teacher observation protocol, or RTOP. And they're observing a teacher working with the math and physics classes, and they're using this protocol. And you'll notice that when observer Y observed a particular case, if they scored that particular case low, observer X also scored them low. And if they scored them high, observer X also observed them high. So in this case, the data and the line, the graph depicts a positive correlation between the two observers. So a graph like this depicts a high reliability for that particular instrument. So now a little bit of practice. Go ahead and read this practice item and then select which form of reliability is being measured. So I'm about to display the correct answer. If you don't have enough time, you might want to put this video on pause. So in this is a case in which alternate form reliability is being measured, because in this case there are two alternate versions or alternate forms, and the teacher just wants to try and correlate the performance on one version and another. And if the teacher has enough students to do this, then the correlation should be pretty high. That is, the way that students who get one version perform should be similar to the way they perform on the other version. The last concept related to reliability that needs to be presented here is something called the standard error of measurement. And the reason why this is important is because this particular statistic is reported on many types of standardized tests, and it's addressed in the book, but I wanted to point it out here. The purpose of calculating the standard error of measurement is to estimate the consistency of an individual's test performance on how well they might perform on an equally difficult or easy test. So it's similar to kind of the plus or minus percent on a polling statistic, where you collect data for a poll and then you can say that here are the results plus or minus this these number of points. And again, this is important, and if a student or a parent ever asks you about what the standard of error means, you can just tell them that it means that if it's a range of performance that would statistically be probable if a learner were to take a similar assessment. And it out here. Here is a graphic from a research article in which test performances are being reported, and you'll notice that standard error of measurement is actually included as one of the important pieces of information that is reported about learner performance. And so it's important just to have a general understanding of this. If you are a teacher in Virginia and you provide standard of learning test results to parents or students, this will also be reported. And again, it shows you it gives you a range of how well that particular score would be if the learner were to take a similar type of assessment in the future.